Hi, welcome to Teardown Tuesday. Yes, we're going back to the future of computer technology today, right back to 1977, where it all began. One of the pioneering computers of the modern era and one of the biggest selling computers that a lot of people forget about. Everyone remembers the Apple II and computers like that, but well, this thing was actually the biggest selling computer of its day back in the late 70s. This is the Radio Shack TRS-80 Model 1. If you don't recognize it, it's an absolute classic, and thanks to one of my viewers, Ben, for loaning me this thing so that we can tear it down and take a look at it. There's not a huge amount in these things, but it'll still be very interesting retro technology. I love this, and look, it's fully working. No problems whatsoever. 37 years old, and it boots up just like that. Now, way back in the mid-70s, an employee called Don French at Radio Shack actually bought one of the MITS Altair kits, one of the first do-it-yourself, the first do-it-yourself hobby computer in the world. That's what started the revolution. He thought it was fantastic, started designing his own computer, and he eventually convinced Radio Shack that they should jump on this bandwagon and produce their own computer, which they started to design it in 1976, and it was released in 1977. And you've got to remember the market back in 1977, there was basically nothing out there. There were three major computers released in 1977. This TRS-80 Model 1, the Commodore PET, and the Apple II were all released in 1977, and they were the big three competing it out. And this one actually won out at the time, and this was the highest selling computer of its time. It even beat the Apple II at the time. So it was incredibly successful, mainly due to its low price point, and they really screwed the bill of materials on this one. For example, it only displays uppercase characters, and supposedly that took $1.50 off the BOM cost, which took $5 off the retail price of the computer. So that's how desperate they were to get a really low price point. And this machine was released at $600 back at the time, and that was just the computer unit itself. That didn't include the monitor, which wasn't really a monitor. It was just a regular TV that they called a monitor. You could have actually used anything with it, really, but this is the original monitor that came with it, black and white. And it was originally released in 1977 with 4K of RAM, expandable to 48K, but 4K as standard with level 1 basic, although that machine didn't last long. And by the way, that machine did not have the numeric keypad. So if you've seen some photos of this old Model 1 and they don't have that keypad, that's a very early unit which didn't last very long as well. They added the numeric keypad fairly quickly after the introduction of that. So this one actually has it. This one's a 1978 vintage unit, serial number, couple of thousand, as we'll see soon. But then they quickly upped the RAM as well to 16K of RAM as standard, expandable to 48K, and then a 12K level 2 basic in ROM. That was a cut down Microsoft basic from their 16K basic. It was cut down to 12K. Really cutting that cost down ensured the computer's success, but they thought that they'd only sell a couple of thousand of these a year. It turns out they sold orders of magnitude more than that, and it was wildly successful and outsold the Apple II and the Commodore PET, which were the two major competitors. And $600 back then, about $2,300 in today's money. Woo! And of course it had stunning specs. Both the Apple II and the Commodore PET used the 6502 processor running at 1 MHz. This used the classic Z80 processor and ran it at 1.774 MHz. So significantly faster. I'm not sure of the actual benchmarks, but raw processor speed was actually faster than the Apple II and the Commodore PET. And other stunning features, full stroke QWERTY keyboard, of course, absolutely better than that Commodore PET chiclet keyboard thing, and uppercase only text, as I said, because they wanted to shave a couple of bucks off the cost. 64 by 16 character display, and basically didn't have a graphics mode, although the characters could be divided up into little smaller pixels, so it effectively did have a graphics resolution of 128 by 48, and that's what you're seeing here. I wrote a little basic demo program, and they're the actual pixels on the screen. I'm turning on and off individual pixels, 128 by 48, black and white only, none of this color rubbish. Now, as it turns out, it didn't last all that long. They replaced it in 1980 with the Model 3. Now, there was a Model 2, but that was earlier, but that was aimed at business users and priced at a different market. So it effectively was replaced by the Model 3. So it only had a 3-year lifespan, if that. And basically, the reason for that is because it didn't meet the new FCC requirements. This thing just spewed out the RF like there was no tomorrow and swamp nearby AM radios and things like that. And we might actually check that later on the spectrum analyzer and see what we can see from this thing. And this thing actually had double precision floating point basic. Can you believe it? Oh, state of the art. And as with all machines of the era, yes, you basically stored your programs on cassette tape. So you could buy a separate cassette tape recorder with it. And eventually they released a unit which sat under the monitor, an expansion unit which could hold floppy drives. Woohoo! So a lot of people remember the Apple II as being the computer that sort of pioneered the industry. Well, you could argue that this one actually pioneered it. I mean, the Apple II had color and, you know, stuff like that, but hey, this thing was cheap and it outsold the Apple II back in its day by a fair margin. So this was the most pioneering and popular computer of all time, arguably. Sorry, Apple II fanboys. But yeah, it was pretty much a heap of crap, really, this Model 1, and that's what earned its nickname the Trash 80. So to speak in the language of the era, this is the Trash 80 from Rat Shack. Beauty. So here is what you got for your $600 back in the day, or $2,300 in today's money. You just got the computer itself with the power supply. That was it. The monitor was extra, as I said. The tape deck was all optional extra. So there you go, $600 bought you a, well, basically let's go with the 16K level 2 basic machine with the Z80 processor running at 1.774 megahertz with that basic in ROM booted up, and that's pretty much all it did. Now this one does have some extra labels stuck on here by the owner, and that wasn't part of the original keyboard at all, but you know, it's basically not a bad keyboard. It's a nice full stroke thing, and you know, separate numeric keypad, which I said the very early models there were only a couple of thousand or something at most that had the that didn't have the numeric keypad in it. So you know, it was really quite a usable machine from the keyboard perspective, and it was all built into the one thing. And well, yeah, it was built down to price and limited functionality with the 64 character by 16 line display and sort of the effectively zero graphics, no color, stuff like that. There was no sound in this thing, by the way. Couldn't even generate sound, although with all the RF emission you could actually put an AM radio nearby and get some squawks out of the thing, or hook it up to your cassette tape interface and you can make the cassette make sounds happen through the headphones on the cassette deck or something. But yeah, but hey, this is not a bad computer at all. Full stroke keypad, thumbs up. And here's the keyboard on the thing. Sorry about the flicker, that's just the frame rate of the refresh rate of the screen against the camera frame rate here. I can tweak that, but what's the point? And yes, this was an RCA TV, and they basically just retrofitted it to work to be a monitor and sold it as a monitor. And look, this is the original cable. There's no grommet in there. I've been told by the owner who originally bought this thing that it didn't have a grommet. This is how it came, and you basically had brightness and you had contrast and power, and that was basically it. And yeah, black and white only. Later models were replaced with a green screen one, but this is one of the early units. And I know you can't wait to see this thing boot up, so here we go. Let's turn it on. Ta-da! memory size, I don't know what to type there, so we just hit enter, and there it is, Radio Shack Level 2 Basic. Actually, I believe that memory size one is an older version of the ROM. The newer one actually saved a few bytes by just putting mem size or something like that. And there it is, the Trash 80 microcomputer system, custom manufactured in the United States of America. By Radio Shack, Fort Worth, Texas, 76102, catalog number 26-01006. This is a really low serial number one too, by the way, in the scheme of things, because they sold a couple of 100,000 of these, and this is sub 10,000, 9,529. So not bad, especially considering that it was sold here in Australia. In fact, it would have been one of the very first ones in this country, because the owner of this, his family actually ran a, Tandy as it was called here, a Tandy dealer in Australia. So they got one of the very first machines into the country, and you can see the stuff through there. We can see the large electrolytic caps in there, and unfortunately he's already voided the warranty on this thing. Gosh darn it. But it's actually not a bad design at all. They've molded in the little angled standoffs here, so the keyboard goes up at an angle. Plus, of course, you can get through to the huge number of ventilation holes here. You can see the board right through there, but that allows ventilation come up through here. There's no fan, of course, but and then vents on the back of the thing here. And here's the expansion interface, which went off to either the printer adapter, which I do have. I'll show you that in a second, or the floppy drive adapter, or the floppy drive expansion interface. And pretty much there wasn't much else. There was the power button on here, real clunking power button, none of this soft power rubbish, and you basically got power input, video, and the cassette tape interface. And look, they all used the same 5-pin DIN interface, so you could I don't know what would happen if you accidentally plugged the power connector into the video or the tape, but geez, that's just no good at all. But these DIN connectors were all the rage in these computers back in the day, because they were so dirt cheap and readily available, and so common to the designers of the age. So hey, they were used in everything, as crappy as they were. And curiously, there is actually a switch hidden away in here. It's even got a key top on it. I'm not sure if that's part of the original design, but if I hit it, it basically is a brake key pretty much. And this is the original Centronics printer interface for it. It's just got the card edge connector, which plugged into the expansion connector on the back, and it went off to your printer. And basically there's just a couple of 7.4 series logic in there. That's about it. Well, let's crack this sucker open. I know everyone wants to see inside. Oh, a big long self-tapper screws there. It's not going to be terribly interesting, I'm afraid. It's going to be one big board with all these are different size screws. I better keep them in the right location. Yeah, one big board with all dip through hole technology, of course. Classic for the day. And I think we may have a screw in the wrong place. Anyway, let's have a look at the design of it. Oh yeah, these are lengthy screws going the okay. Alright. Slightly different length screws because of the angled case, and we should be in like Flynn in a second. And they probably had a few changes. There were mods for this thing. You could do a hardware mod to take it from level 1 to level 2, for example. So here we go. Is this gonna, yeah, that's off like that. No, there's actually, yeah, one big keyboard. There's actually an expansion thing down here. Whoa, okay. There's a couple. Look, that's must be a keyboard interface keyboard. I thought it was all on one board, but gee, apparently not. Now, if we take out our keyboard here, it mounts on some posts, but yeah. And Japan, manufactured by ALPS in Japan. Fantastic. They were the leaders of key switches back in the day. Kind of still are. And like I said, this is a 1978 vintage one. There it is, copyright 1978, Tandy Corp. The monitor was also manufactured in 1978. And of course that would be right based on the serial number of just under 10,000, because this was released in around about October 77. So yeah, the 10,000th unit would have been manufactured sometime in 78. And the construction is exactly what we'd expect of the day in terms of the PCB. Double-sided, we've got tin roll plated traces before it was the solder mask was put on top, so you end up with those crinkly and raised traces with the tin coat on them. I'll show you, get the macro lens and show you that up close. Of course, the keyboard was manufactured in Japan, the ALPS keyboard, so that's why the PCB material, everything looks different. Would have been done by ALPS and sent as a complete module to Radio Shack, and they would have just whack that on there. But the PCB, I assume, would have been manufactured in the US. It was certainly assembled in the US and tested. And there you go. That's what I mean by those crinkly traces there. You can see that it's basically the copper trace is all raised up because it is a tin roll coated before they put the solder mask on top of that. They don't do that these days. Of course, they do SMOBC, or solder mask over bare copper, but back in the day this was very common, so it looked like it was all bubbling up and peeling off and the solder mask, but it actually wasn't. That was the tin plate under there. Now, believe it or not, what's holding this board in like this is not this screw here, that's just holding a heatsink underneath, is actually these things. They're, I don't know, they look like dried up double-sided tape, but they're not. They're something else entirely, but they're rather weird. Kind of spacers. I have no idea what material that is. It's absolutely bizarre, but some of these are well and truly stuck on. I certainly didn't expect to have to dig into something like this to try and get a board out. That's for sure. This one is the only one left, and it's crumbling, or starting to draw some blood there. And these boards, you've got to be careful. You slip the dip pins on the bottom, extremely sharp. You can really give yourself a nasty cut. With a little bit more persuasion, it did actually slide off. So we should now be able to lift the board out, ta-da, from the case. And we're in like Flynn. And this is actually a beautiful PCB. Why do I say that? It looks a bit, there's a few hacks and bodges on there, but it's basically very well laid out and is very typical of the era. And my hat's off to whoever laid out this board, because I can't see a single jumper link anywhere on this board. And that is always the holy grail of any PCB layout engineer, is to basically get 0 jumper links. So you've only got a double-sided board like this. It's not like they've given you the luxury of 4 layers and you can have a big ground and power plane and everything else. No, you've only got 2 layers, and they've basically laid it all out in very traditional style for a double-sided layout like this, in nice rows like that. All the chips sort of line up in beautiful columns like that, and they've arranged it so that there's 0 jumper links. There might be, I can't see one. I will stand to be corrected on that, but that is, it's just beautiful. Thing of beauty. Joy forever. And the actual circuit design, very typical of the era, of course. It's not like a Sinclair, which tried to reduce it all in gate arrays down to a couple of chips and things like that. They were in the future, in the 80s. But back then, basically, you've got the Z80 processor here, you've got your RAM, and you've got your ROM, and everything else is basically just standard 7.4 series, what is it, LS? Yeah, 7.4 LS series logic, pretty much everywhere else. There looks to be one particular device which is not standard, and that's the only one which is socketed, by the way, so we'll have to have a good look at that one. And curiously, these are obviously the ROMs here, and they've taken, that's what that board on the back there is. So they've taken this ribbon cable with this dip header here off to that board on the back. That's the level 2 ROM upgrade, because if you bought a level 1, they would actually upgrade it for free, I believe. If you send it back to Radio Shack, they would do the hardware upgrade to upgrade it to level 3. That's why when we flip it over, we'll see a few bodge wires on the back. Room enough in those 2 sockets, so they needed the expansion board on the back. And there you have it, a couple of bodge jumper wires going from various points over here over to the board with 3 ROM chips on here. Let's take a closer look at those. And by the way, just looking at the routing on this back of the board, they've done a really good job. As an experienced PCB guy who's done many of these countless double-sided layout boards like this, you can tell they've got this pretty much right and optimal. Trust me, it's not easy laying out a double-sided board like this, and well, they've done really well. Manufactured by NEC here. These are mask ROMs, and you can tell it's a ROM set because they've basically got this part number you've never heard of, and then A, B, and C there. So yeah, it's a 3-part ROM set. And of course it needs 3 ROMs here to make up the 12K ROM. So these would be 4K each. 4, 8, 12. Beautiful. Whoa, there's the money shot. Look at that. MOSTEC Z80 CPU. None of this Z80A rubbish running at 4 megahertz. Oh no, sirree. 1.774. Thank you very much. Is that a date code in there? Look, 7905. So maybe this isn't a 1978 unit, but a very early week 1979, because these things wouldn't have been sitting around in stock, right? These would have gone straight out. So this thing probably only was manufactured, this machine, like maybe a couple of weeks after this chip was made, would be my guess. So if we look at some of the other date codes here, yeah, like late 38th week 78, 51st week 78, this one very early 79 as well. So it looks like, yeah, the first dozen weeks of 1979 this was manufactured. And likewise for the RAM as well, there it is, classic TMS 4116, yeah, the 6 weeks 79 in that classic ceramic package. Oh, I love it. They're vintage stuff. And these are one of the early dynamic memories. They're not SRAM, which was typical of the very early computers. So that's why you could afford 16K back then in DRAM. And the -30 there, that indicates 300 nanoseconds access time. Oh, slow as a wet week. And check out the pins on this Z80 here. Look at that. They're gone all tarnished, have they? Or has some of the plastic sort of leached out? I don't know what's going on there. Ugh. And that Motorola chip, as I said, is the only other oddball one out that's not standard 7400 series logic here. So it's an Motorola 8046670. Bit of a Google on that. Turns out that's the character generator chip, and it was the same one apparently still used in the Model 3. So yeah, that'd be some sort of gate array holding the various characters for presumably only the uppercase stuff. And we got ourselves the main regulator there on its own little low profile heatsink. It's probably good enough. Didn't hear any complaints about this thing overheating, but I stand to be corrected. Anyway, it's the 2N6594 PMP part in a standard TO3 package. And well, that was a common way to mount, still is a common way to mount TO3 packages onto a PCB like that. So no problems whatsoever. I don't like this freestanding tip 29B just hanging its ass out over the edge there. Jeez. Well, I guess if you're not living life on the edge, you're taking up too much room. We've got a couple of big ass electrodes happening there. Look at that, 10,000 mic. Thank you very much. Along with a 2200 mic, 35 volt one. Crikey. But hey, this thing would suck a lot of juice though. I mean, these dynamic RAMs here take half a watt a pop. And there's a couple of crusty old pots there to tweak your cassette interface. Make sure you have your tongue at the right angle. And there's the main crystal, 10.6445 megahertz. So that was divided by 6 to get your main processor clock, which is precisely 1.774083 repeater. There you go. It was slightly above. This sucker was overclocked from its nominal 1.774 meg. Beauty. Well, it's no wonder this thing didn't meet any FCC requirements, and basically they had to stop selling it, replace it with the Model 3 because of that. They couldn't get it certified. I mean, you know, you got no ground plane in this thing to take care of anything. Probably the power layout is, you know, it's pretty standard for the day, but maybe they didn't have enough decoupling on it. But look, you know, when you start adding memory interfaces, big parallel buses running like this, I mean, you're just asking for it. And your expansion interface basically just, once again, you got long unshielded ribbon cable just going off willy-nilly to your expansion box. You can't have that. And there's no metallized shielding inside the case or anything like that. Is nothing. Hey, somebody signed that, have they? There you go. Love it. But yeah, none of that. So no good whatsoever. I don't see any chokes or anything else on any of the I/O lines. Nah, it's just not happening. And for those who are keen, here is the back of the monitor. There you go. Manufactured 1978. Oh, how crusty this thing is. Unbelievable. And for those who absolutely must see the crust for themselves, hey, look at this. Beautiful. Look at that. Oh yeah, that's got 1970s RCA written all over it. You betcha. And that is the model KTR 124SA. Oh yeah, look at some of that. Some tagboard action going on down in there. With that resistor with a lead wrapped over it, holding it in place. Oh man. Woohoo! This is fantastic stuff. Sorry about the handheld work here. Oh yeah. But hey, I guess we shouldn't knock it. It is still working after 37 years. So, well, you can't complain. And apparently, no, it hasn't been repaired. This is factory original. Okay, let's have a quick look at this on a spectrum analyzer. I'm going to use the Tech MDO 3000 here. So I've got nothing connected on the input. I've got 0 to 10 megahertz span here, and resolution filter of 300 hertz, and that is our baseline. There it is, basically all below minus 105 dBm. So there you go, there's nothing at all. And if I now plug in my antenna, it'll take some time because of the narrowband filter there, but look at that. Ta-da! There we go. There is our second harmonic right there, 1.774 megahertz times 2, roughly 3.56 megahertz. By the way, as far as the antenna goes on here, I've just got one of these whip antennas. I could probably move it down like that or do something. Whoa, there we go. Our noise floor just jumped up fairly drastically. Let's keep it like that, actually. By the way, this thing's really slow to move these cursors. It's a dog when you've got the filter set so low. It's got to muck around and do a lot of processing, and it just basically just locks up the front panel control there. Really slow. Anyway, there is the fundamental 1.76 megahertz. There's the second harmonic, and so on. And I've changed the resolution bandwidth to 10 kilohertz there, and you can see how it's just much more responsive on the cursor now. Or a little bit of a jaggy in there, but basically work in real time. So yeah, it doesn't like to be doing any heavy background processing there. You can see all this crap down at the low end here. I mean, it's just, or like, you know, sub 1 megahertz and stuff like that. It's just garbage, and that's why the AM broadcast band is just being swamped. And there's from 0 to 2 megahertz with 100 megahertz resolution bandwidth filter. And you can't even call up the bloody menus when this thing is just chewing all that, doing all that processing at that very narrow band filter right down at the bottom. Oh, it's just painful. It's practically locked up. Really, I mean, no, it just did something then sporadically. Unbelievable. And just because we can, let's compare the Spectrum with the Trash 80 Model 100, rumoured to be the last machine that Bill Gates ever actually wrote code for. So I'll run a little program here just to loop it through, and we'll see what we get on the Spectrum. So there we go, I've got the antenna directly over the thing. You know, this is just mucking around really, so no people complaining about that I'm not doing it right, just mucking around. But look at that, pretty clean compared to the Model 1, that's for sure, especially down at the low end here. There's not much happening there at all. We're from 0 to 2 megahertz again with a 300 hertz resolution filter. And that there is actually running a program. That's just running a Hello World program. It's just printing Hello World again and again. So relatively clean compared to the Model 1. And if I expand that out from 0 to 10 megahertz, there we go. We can see the main processor clock there, 2.4 megahertz. This is an 80C85, so it actually runs faster than the Trash 80 Model 1. So there you go. That's the clock frequency, then the second harmonic, and so on. And watch this. If I switch the Model 1 on, here we go. So we've got our baseline of our 102 here. So switch that on, and bingo, look at that jump up very, very significantly. Huge jump there. I mean, that's jumping up a good 10, maybe 15 dB there, because we're 10 dBm per division. So it's not really surprising, as we've seen in the teardown, and by the way, I'll link in the teardown for the Tandy Model 100 102 here, which I've done back as well. It's not surprising that the Model 1 here is much noisier, a much bigger emitter than the 100 series here. This sucker, not only did it have, you know, huge bus lines running everywhere, but we're talking about not the huge current consumption in just the DRAMs, for example. As I said, those DRAMs will take like half a watt a chip or something like that. That means huge big current spikes in there, and when you include large current spikes with big loop areas inside there and like power loop areas, then, well, you know, it's just going to emit pretty horribly. Whereas something like the Model 100 here, really low power one using SRAM, we've got much lower current spikes on the transitions and things like that. So really, you know, no surprise whatsoever. And yep, I'm still trying to get over how awfully dog slow this thing is on those low resolution bandwidth settings. It's just, it's practically almost unusable. Unbelievable. I don't know what the hell they're doing in the processing architecture of this thing, but oh, they really need to fix it. I know you actually get the Spectrum Analyzer plugin for free on this thing now, which is, yeah, great, but geez, at least get that working. Unbelievable. Oh. So there you go. I hope you found that retro teardown as interesting as I did. The Trash 80 Model 1. Ah, oh, does it get any more classic than that? Unbelievable. Let's break our little program there. And CLS and list. Ah, oh, it's just too good. Oh, by the way, I didn't show you the power adapter. There we go. It's just a big Trash 80 power adapter. A big linear transformer by the weight of the damn thing. And there you go. I had fun looking at this, and I can't believe it still works after 37 years or whatever it is. Close enough to that. Unbelievable. Still works like the day it was bought out of the box. Fantastic. How many other computers can still claim that? Terrific. Anyway, if you want to see the high-resolution teardown photos of this, I usually take high-res photos. They're on eevblog.com. That'll be linked in down below. And as always, if you like Teardown Tuesday, please give it a big thumbs up. Catch you next time.